Okay, so this is question number 28 of the Magnetic Fields homework booklet. So in question 28, we are looking at an oscilloscope, and this oscilloscope is being used to investigate various voltage sources or various sources of potential difference. In order to do this, a voltage source is connected to the Y input. Now, the Y input is one of the channels that you can connect electricity supplies and wave supplies and things to on an oscilloscope. So the term Y input, as we'll see in a bit, is quite important. And we're told that the time base is switched off. Well, if the time base is switched off, what that really means is that this dot that's normally on our oscilloscope does not move side to side. So there's no side to side movement at all. The dot will stay in the centre no matter what it does. And in figure 1 here, this shows the screen of the oscilloscope when the Y input is not connected to any voltage source at all. So in other words, the time base is switched off, there's no voltage input at all, and our dot is in the middle. So basically it shows us where the dot starts off. In figure 2, they then connect this oscilloscope with the time base still turned off to a 1.5 volt cell. Now, a cell is a direct current source, so basically it's not a sinusoidal source, so it doesn't alternate. It's a direct current, so the dot, if it moves upwards, then basically it will stay in that position once you've connected it to your oscilloscope. Now, the reason that they've given you this is so that you can work out what the Y gain setting is, because if we know that this thing is 1.5 volts and it's moved up by 3 squares from where it started off at, that must mean that every division or every square is worth half a volt. So each one of these squares, every time it moves up, is worth 0.5 volts, and we'll be able to use that in the rest of the question. So then finally we actually get to the question. So part A, we're given this grid and we're asked to show the appearance of this screen if the Y input is connected to a 2.5 volt DC supply now. Now, as we saw before, each square is worth 0.5 volts, so the Y gain is 0.5 volts per division, and we want to go up to 2.5 volts. So simply we just have to go up 5 squares because every square is worth half a volt. So we go up 5 squares and basically just put a dot. It won't be moving up or down or anything like that because it's a source of direct current. So simply the dot just stays there. In part B, they now take the Y input, so they take the input to our oscilloscope and they connect it to an AC voltage supply that's a sinusoidal one. So this is an alternating current. So the current will go one direction and then back in the opposite direction and so on. And they see this thing. So all they see is a line like this. And we're asked to explain why this vertical line is seen. Well, it's seen because the potential difference changes direction, and this makes the spot basically move up or down, because at some points it'll go up to a positive maximum value, then it'll go down to the maximum negative value, and then back to 0, and it'll just keep doing that. And the reason it does this is because the time base is turned off, and so the dot's just going up and down, so you just see a line. But for your 2 marks, you simply have to just write these 2 things here down. We're then asked to calculate the peak-to-peak voltage of this AC supply. So again, we'll go back up here. What we can see is that we've got the actual length of the line is 4 squares there, 4 squares there. So the length of the line altogether is 8 squares. And it's the same oscilloscope. We've not changed any of the settings. So if it's 8 squares from the bottom to the top, then the peak-to-peak potential difference, which is the potential difference from the very bottom value here to the very top value up here, is 8. Every square is worth 0.5 volts. We've got 8 squares, so the peak-to-peak potential difference is just 4 volts. And then finally, we're asked to calculate the root mean squared voltage of the supply. Well, we know that the peak-to-peak voltage is 4 volts, so that means we can work out what the peak potential difference is. So that's 2 volts, and we need that because the only way we can work out a root mean squared potential difference really is if we know the peak potential difference, because if we know the peak potential difference and we divide it by root 2, it gives us the root mean squared voltage. So we take our peak potential difference of 2 volts, we divide it by root 2, and it gives us the 2 significant figures 1.4 volts. So that was question number 28 of the Magnetic Fields homework booklet.